Welcome to GMST Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 2, that is Sumpner test on similar transformers and determine the determination of the combined and individual transformer efficiency. So this test is conducted on two identical transformers to obtain the graph of efficiency versus the load and regulations versus the power factors. So these are separate is required. We require the single phase transformers, that is 2 kV rating or 230 voltages, two numbers. Then we require the auto transformer, that is 0 to 300 volts, 10 ampere, one number, digital ammeter, digital voltmeter, and multifunction meter. And you require the few connecting wires. So theory: the Sumpner test on a single phase transformer is also called as a back-to-back test. This method is to evaluate the performance of two identical single phase transformer under the full load conditions while consuming very little power. So this test will help us to measure the efficiency and also the temperature rise due to the both iron losses and the copper losses. So this test is the principle behind the open circuit test is also comes into the picture. That is, we can determine the measure the core losses which occurs in transformer under the normal operating conditions. Under the short circuit test, we can measure the copper losses which occurs due to the flow of current in the windings under the loaded conditions. So this is actually the circuit diagram. So you can see from the first multifunctioning meter 1, the input of this multifunctioning meter should be connected to the AC supply. Then output of the multifunctioning meter should be connected to the two transformers. So that is T1 and T2. So P1 and P1 should be shorted. Similarly, P2 and P2 should be shorted. That should be connected to the output of the multifunctioning meter. So whereas in the other side, you can see there is one more single phase auto transformer. Output of this auto transformer should be connected to the multifunctioning meter 2. That is the input of the multifunctioning meter 2. Then output terminals of the multifunctioning meter 2, one of the terminals should be given to the switch, right? We have to connect a voltmeter across the switch. So another end of the switch terminal should be connected to the S2 of the T1 transformers. So S1 of the T1 transformer and T2 of the S1 transformer should be made a common point. Then S2 of the T2 transformer should be connected to the remaining terminals of the MF, that is multifunctioning meter 2. So this is a procedure. So we have to make the connection as per the given circuit diagram. The supply switch is closed, keeping the single phase auto transformer in the minimum, and a single switch S3 should be in the open positions. So here you can see this is the supply switch, and this is the switch which is called as a S3 switch. Here in the S3 switch you have to kept open. So the thing is that you have to check whether we have to observe the across the voltmeter which is connected across the switch. If it reads 0, so we have to see here across the switch we have connected a voltmeter. Suppose if it reads 0, then we have to close the switch, right? Then you have to close the SPST switch. Suppose if it reads double the voltages of the transformer, so that is across this switch, if the voltmeter reads double the voltage of the transformer, that is 230 and 230, 460 voltages, then we are not supposed to close the switch. Then we have to interchange any one of the secondary terminals of the transformers after opening the supply switch S1 and S2, right? So we have to then we have to increase the auto transformer voltage such that the ammeter A2, that is, reads the rated current of the transformers. Then note down the readings of the wattmeter W and the ammeter readings. So auto transformer voltage is reduced to 0, then the switch is open, and then we have to switch S1 and S2 should kept in the open positions. So this is actually a tabular column. We have to take the readings of V1, I1 from the meters. Then you have to see what is the power, that is W1. Similarly, we have to note down the V2, I2 and W2. So these readings can be taken from the multifunctioning meter 1, and V2, I2 and W2 should be taken in the multifunctioning meter 2. So this is all about the calculations. If you want to find a wattmeter constant, we can use this formula Vi cos by full scale readings. Then these are the calculations. To find the iron losses, we have to find what is the Wi. Then we have to find out the copper losses, that is Wc by 2, because we are using the two transformers, right? So R equivalent is given by Wc divided by I2 square. So Z equivalent is equal to Vsc divided by Ac, and X equivalent of the transformer is under the square root of Z equivalent square minus R equivalent square. So this is the tabular column to find out the efficiency at the different load conditions. We are just assuming a fractions of the full load conditions, that is 1/4 load, half load, 3/4 load, and full load are 1/8 loads. So this equations which is used to determine the your efficiency of the two transformers. That is x into x is here we have to use the x, that is the fractions load. kV rating is there, we have to use the whether if it is 2 kV, then you use the 2 into 10 power 3 into power factor. So right, what is the power factor we got from the readings? We have to note on the power factors divided by x into kV rating into 10 power 3 cos phi plus WOC. That is a we have to take the readings from the WOC and WSC, we can take the readings from this W2. So right, so this is the formula to find out the efficiency. Right, take the power factor as a 1 and take the power factor 0.8 to find out the efficiency of the transformers. Right, this is the expected graph. So you can see, as I told that power factor can be taken as a 1 and power factor can take you can take it as a 0.8 or 0.8. And this the plot should be we have to plot the graph for the kV rating as well as the efficiency. So we have to see what is the fractions of the load should be taken in the x-axis and the efficiency should be taken in the y-axis, right? So we have to, in the x-axis you have to take the half load, foot load and the 3/4 load and 1/2 load or 1/4 load. Then you have to plot efficiency in the y-axis. Then we are going to get the expected graph for the different power factors. So this is for finding the regulations, that is I rated R equivalent cos phi plus or minus I rated R equivalent sin phi divided by V rated into 100. So this for we have to find out the regulation for the 0.4 lakh, 0.6 lakh, 0.8 lakh for the different lagging power factors. For UPF you have to find also the leading power factors 0.8, 0.6 and 0.4. Then find the regulations using the above formulas. So this is the expected graph. You can see the leading power factors on the left side and lagging power factor on the right hand side, positive regulations on the y-axis and negative regulations on the downward sides. So this is a plot of regulation versus the power factor. So finally we have to determine what is the results we have obtained, that is single phase transformer losses simultaneously efficiency at the different load 0.8 and unity power factor and regulations the different power factor can be obtained. Thank you.
Welcome to GM Institute Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 2, that is Sumpner test. So Sumpner test is also called as a back-to-back test. So in this test we have to determine the efficiency, regulations and power factor of the transformers. So this test is conducted by using identical transformer, that is 2 kVA and 2 kVA. So now we have to make the connection as per the given circuit diagram. So after making the connection you have to close the switch. So once you close the switch, we have to see what is the voltage across the voltmeter, that is across the switch. So if it is reads less than 10 volts across the switch, then we have to disconnect the terminals of the voltmeter. Suppose if it reads double the voltage, so that is 230, 230, 460 voltages, then you have to interchange the terminals of any one of the transformer on the secondary side, that is S1 to S2 or S2 to S1. So now we can the voltmeter reading is less than 10 volts, that is 1.9. Now we can disconnect the terminals of the voltmeter. Now we have to close the switch from off to on condition. Now vary the auto transformers till it reaches the rated current of the transformer, that is 2 kVA. So we have to, what is the 2 kVA rated, I rated, it is 8.6 ampere, 3.7, 4.8, 5.5, 6.0, 7.0, 8.2, 8.4, 8.5, approximately 8.6. Right. So now we have to take the readings of, once we close the switch, you have to take the readings of V1, I1, W1, V2, I2, W2. So now we will take the readings, that is V1 is 234, I1 is 0.39, W1 is 0.056. Now W2, that is V is 31.6, 8.6 is the current and W is 0.250. Now you can see the reading, the V1 is 230, I1 is 0.3, W1 is 0.00552, V2 is 31, I2 is 8.6, W2 is 0.024. Now you have to off the switch, you have to reduce the voltage and off the switch, then disconnect the main supply. Thank you.